size. So what we're talking about? We're talking about different possibilities to avoid deadweight loss from monopoly. So number one, prevent monopolization. That's the easiest way, and that's why we have antitrust laws. Number two is pretty much hoping that price discrimination would take care of the problem. And so number three is regulating something called natural monopolies. So let's talk about price discrimination first. So price discrimination, as I mentioned in class, is basically a situation when companies are charging different prices for their stuff. So they're selling the same stuff but at different prices. So usually that's because they charge different people different prices. Examples, when you go to the movies, if you're a student, you'll get a lower price, right? Same thing for senior citizens. So the idea behind this approach is not because they really feel for you guys, but because they want to get more students going to theaters, right? Without lowering price for people who can afford to pay a higher price. So it's all about profit maximization, at least like that's usually the way we look at things in economics. And imagine a situation of perfect price discrimination. Perfect price discrimination is when actually every customer paying the highest price they're willing and able to pay. Interesting. I just wanted to get rid of this. All right, so perfect price discrimination, that's a situation when every customer paying the maximum that he or she is willing to pay. So how is it going to show on our diagram? If this is our demand curve, so this is price. Well, that's what demand curve shows, right? Also it shows marginal benefit. So what will happen in this case? Perfect price discrimination is that, as the company is selling, let's say it starts with the highest paying customer. So it sells first unit to this guy, he's paying that much. Second guy will pay less because we rank them, right? And we started with the highest paying one. And you pretty much keep going and you collecting all these revenues for each additional unit. So you're charging different prices. Okay, and it's quite a difference compared to a single price monopoly. Remember, for a single price monopoly, the company just sets like a given price and then it sells certain quantity which basically matches this price. So P1 allows it to sell Q1. But like if this company decided to sell, let's say Q2, there is no single price. I mean, actually the revenue is going to accumulate will be this area. So it's not a rectangle, it's this differently shaped area. So it's not just like, you see, like if it was a single price monopoly and it wanted to sell that much, right, Q2, it will just set price here and collect this amount. But a price discriminating monopoly can collect more. So actually we can separate it like this. That's what single price monopoly will collect when selling Q2, amount Q2, and the yellow area shows what the price discriminating monopoly will collect. Okay, so what does it mean for us in terms of efficiency? Why it's going to change efficiency? Well, to understand that, we need to understand what's happening with marginal revenue in this case. Remember again, in case of single price monopoly, if this is your demand curve, your marginal revenue is this thing. And that's why monopolies underproduce. They will produce at this level, right? Where marginal cost meets marginal revenue. And it will be different, this quantity will be smaller than this quantity. Because this is our demand curve, which tells us what marginal benefit is. So this is the point of allocative efficiency. And that's the amount monopoly will produce to maximize its profit. So that's why marginal revenue is important. And simply put, what happens in this case of perfect price discrimination is that marginal revenue becomes equal to price. Just like in case of perfect competition, but for a different reason. And why it's equal to price? Well, just because things work just like I explained. Every time you add an additional unit to your sales, you see, like let's say this one, you don't have to change price for all other units. Let me use a different color. So you see, all these prices stay the same because every customer is paying, well, unique price for that person. So every time you're adding one extra unit, you change your total revenue exactly by the amount you're charging for it. And so that makes marginal revenue equal to price. Okay, and that means that the monopoly will keep reducing as long as its marginal revenue curve, which is the same as marginal benefit curve, right? Because this is what's going to happen, and that's the key thing here. This, well, let me maybe redraw it, or maybe I'll show it here. So you see, demand curve is the same as our marginal revenue. So this is marginal revenue, which is also price, which is also marginal benefit. So instead of stopping here, if we look at this diagram, instead of stopping here, monopoly will follow this curve because now this is where its marginal revenue is, and it will just go all the way here, and it will stop here, maximizing its profit, and it also will happen to be the point of allocative efficiency. Very good. So that's the good thing about perfect price discrimination. Even though, as I again mentioned in class, the downturn of this for consumers is that in such a case, the entire consumer surplus will be absorbed by the company. Okay, so it's 7 minutes and a half, so I better hurry up. Next thing, let's talk about natural monopoly. Natural monopoly is a company whose ATC curve is downward sloping all the way for the entire range of demand. And eventually, I mean, generally speaking, this curve, ATC curve, has a normal looking U shape as always, right? But it's stretched so much like this. And basically what's happening, we're looking only on this left side. So basically this thing is the left side of the normal U-shape curve, which happened to be stretched so much. And it happens to stretch so much for companies which have very big share of fixed resources in their production, like railroad companies, gas transmitting companies which deal with pipes, electricity transmitting companies, basically everywhere where having one big piece of equipment makes more sense than having like a bunch of smaller pieces of equipment. And in such a case, having one company just makes sense. So that's why it's called natural monopoly. So having one company just makes sense. So splitting industry between different companies to improve competition wouldn't really work in this case. Okay, so if this is the case, how are we gonna, what can we do in terms of regulation? Because now it comes to regulation. So imagine that you actually can tell this company what to do. What would you do in such a case? Let's actually draw some more pictures here. We need demand curve. Demand curve, which is again price, shows us price and also shows us marginal benefit. And we need marginal cost. And marginal cost is going to look like this, almost like straight horizontal. I mean, again, the thing is that eventually is going to catch up with, all right, I think it looks better. It's gonna catch up with ATC, right? Just again, doing this. But it's going to happen somewhere, you know, there, so it's out of sight for us. All right, this is, sorry, not MC. Okay, and if this is our marginal cost curve and this is our marginal benefit curve, then we can find the point of allocative efficiency. Remember, it's where MB meets MC. And again, the logic is we want to produce all units for which MB exceeds MC. And that means we want to keep going as long as demand curve lies above marginal cost curve. Okay, and simply put, if you want to have, if you want your company, this company to be at the point of allocative efficiency, so it doesn't generate any deadweight loss, doesn't lose any surplus, you want to push it just to this point. You want to push it to this point. Well, however, there is a problem. If you push it all the way here, well, assuming it's a single price monopoly, right? It will have to lower its price, to sell this quantity. Basically to this level. Okay, so what's the problem with this price? The problem is that this price at this quantity will not cover average total cost. Let me change the color here. Okay, so let's see if you go up from this quantity, doing the usual thing we usually do, right? P minus ATC times Q tells us what profit is. You will see that, your ATC in fact exceeds your price. So this formula will give you a negative number. So the company will be actually losing all this area as negative profit. So losses. And of course, no company can survive in such a situation for, any meaningful period of time. So one possibility in this case, just to provide this company with subsidies. Subsidies. How about giving the company subsidies? Okay, it's possible, but you have to remember that to give someone money, government has to collect this money, take it from somewhere else. And as you might recall, taxation generates deadweight loss of its own. So by trying to eliminate deadweight loss, in this case, we easily can generate it somewhere else. So that's why we're going to look at an alternative. And by the way, what I just described, it's called marginal pricing. Actually, marginal cost pricing, right? Because that's how we pick the point, the level of output. That's where marginal cost meets our demand curve, which is price, which is demand curve. All right, so yeah, this solution has a problem. Technically it's perfect because we pretty much push the company to produce exactly at the point of allocative efficiency, but this loss actually makes things not very nice in this situation. So an alternative, something called average cost pricing. And let's just redraw this diagram. So what do we need here? We need demand curve. We need ATC curve. We need MC curve. And that's it. So this is demand, which is the same as price, which is the same as MB. This is ATC, and this is marginal cost. And simply put, average cost pricing is when we push this company to produce as much as possible. I mean, we try to make it produce as close as possible to this point, because again, that's the point of allocative efficiency, without losing money. And basically, if you want to keep this company afloat, so to speak, so it doesn't lose money, you can only push it to this point. Because beyond this point, let's say at this level, you see, right after this point, ATC gets over the price curve and the company will be losing money. So that's why we want to stop right here, where the company is breaking even. This is where ATC meets price, so the company is breaking even, no losses, no profit above economic normal profit. Oh, sorry, above zero economic profit, which also basically means normal profit. So this is QA average cost, AC. All right, so again, here no losses, no profit. The problem is there is some deadweight loss, right? Because we're actually not getting exactly to the point of allocative efficiency, so we will be underproducing it a little bit. And that will show as this triangle. So there is some deadweight loss. But if you recall how much deadweight loss the company will generate if it was pretty much doing what it would like to do, then this deadweight loss wouldn't look too big. So remember, like this is what we did last time. Does it look right? So if you just figure out its marginal revenue curve, and the way we do it, we just pick a point right in the middle between this point and this point. And then from this intersection, you go up. All right. And so basically, without going into too many details, deadweight loss in such a case will be all this area. Again, if monopoly was doing things on its own without being regulated in any way. So shrinking deadweight loss from this one to this one is definitely an improvement. And again, it's not giving us zero deadweight loss, but it saves us the trouble of dealing with a company which is losing money, like in this case. So, and that's the difference between average cost pricing and marginal cost pricing.